Okay, that looks right. All right, so if you weren't here yesterday, I went over stuff in this thing about methods for measuring ocean currents, and the video from yesterday will be online anyway, about float devices, propeller, flow meters, and then the Argo project. So that's online, and the videos there are pretty good. So what I want to tell you about now is about El Nino. So here under the plan for the week, uh, there's an assignment here that says El Nino Webquest. It's due Thursday. You have time today to work on it and time tomorrow too. And I'll show you how the websites work for it. There are some links in the plan for the week for this week. So in the plan for the week, it says I'll spend a minute or two talking about El Nino, and there's two videos here. So if you were remote, the best thing to do is go into the plan for the week, and for today's date, this one YouTube video, I'm about to play this one right now, and then play this one right afterward. And so this is like 2 minutes. This one's like 4 minutes. And then I'll show you how the websites work for the El Nino Webquest. Let me get this thing running and whatnot. Let's see. Plan for the week. This one first. Stuff. Okay, so in the folder for chapter 7, there's a thing. It's on the right hand side. So whenever you're in the course and you go like materials on the right hand side, you can get to it in the upcoming for Thursday El Nino Webquest 2020. You can also get to it. The reason why it says 2020 is because the 2020-2021 school year I had to like change it all around and whatnot because we were remote for a bunch of this in the fall. So the El Nino Webquest 2020, whenever you click that, it brings up a Word document, and uh, as soon as you begin to edit it, it makes a copy for you, just like any other kind of assignment. There are two websites that I direct you to in this thing to help you see like what the current state of El Nino and La Nina is. The first one at the top says bit.ly/El Nino 2021. So like, you just go like bit.ly, oops, El Nino 2021. And it is bit.ly's case sensitive, so El Nino has to be in all lowercase. And it takes you to this page, which is part of NOAA's website. So I've said NOAA a bunch of times or referred to it. NOAA is the federal government's uh, agency with the Department of Commerce, the National Oceanic and Atmospheric Administration. The National Weather Service is part of NOAA. So like all weather satellite, weather forecasting comes from the National Weather Service, which is part of NOAA. So it's National Oceanic, so everything about the ocean and the atmosphere. And NOAA, when people think of NOAA, they think a lot about the ocean, but it's also like all the atmospheric stuff. So on the left-hand side, there's individual tabs for weather, climate, oceans and coasts, fisheries, satellites, research, marine aviation. So even like charting, like if you need a chart to like get around, like NOAA's nautical charts are on there and whatnot. And everything is completely free for use for anybody on the planet. So the site that she showed at the end there is Australia's site about El Nino. This is a general El Nino theme page. This is Pacific Marine Environmental Laboratory, PMEL, and it describes what El Nino is. So in the WebQuest, I've got a little link here, like what's El Nino and what's La Nina. Just kind of organize your thoughts. So what's the difference between El Nino and La Nina? You can find information about that here. Like here, what's El Nino, what's La Nina, and facts about El Nino and La Nina. And this site specifically talks about the effect of El Nino and La Nina. So El Nino means like the boy, the little boy. It actually specifically refers to Jesus because El Nino was first described as an effect that we see around Christmas time. But then the opposite is called La Nina. So it's completely has nothing to do with uh, any kind of like religious connotation. We just call it the boy and the girl, El Nino and La Nina. El Nino is a warming phase in the east, and the La Nina is a warming phase in the west, with El Nino, warming phase in the east with La Nina. So there's FAQs here about El Nino and La Nina and the impacts. If you were to click on the impact link, it talks about impacts, like global impacts for the different phases. So this is one way to see it generically. You've got the winter months, like December to February, and the summer months, June to August. So if you're in El Nino, these are the kind of things that you sort of expect throughout the equatorial region. warm and wet, and in the ocean itself. But here in the West, very, very warm and dry. So like warm and dry all throughout the West. And then June to August, like cooler and drier and a little bit drier up here. So these are general, generic climate impacts that you expect to see that affect the local weather. And then for La Nina, these are the other kind of effects. So now when you're in La Nina, instead of this region being dry and warm, now it says like it's wet. So Northern Australia, all throughout Indonesia, the Philippines, um, all these South Pacific islands, generally, those are the kind of impacts you expect to see. So if it's a La Nina year, they get heavy rains and flooding in December to February, and then it's still like wet and cool in June and August. Remember that the seasons are opposite. So June to August in Australia is their winter time. December to February is their summertime, like seasonally. So anyway, that site's pretty good, and it does a pretty good job of describing the effects of El Nino and La Nina. Anyway, the schematic diagram section shows cutaways of the Pacific Ocean during those two cycles. So whenever you're on the first page, let me go back here. These are like cutaway sections. So in normal conditions, the way to read this is the West Pacific. This is the equator here. So the West Pacific and the East Pacific, and this is sea surface temperatures. So you get warm water in the west and cool water in the east, and the wind speed's not really that high. Whenever you're in an El Nino pattern, much warmer temperatures and much higher wind speeds in the east. So red is a false color image showing higher wind speed. In La Nina, significantly warmer water in the west, much cooler water in the east, and much lower wind speeds. So these are like typical conditions. The other way you can see it is this cutaway. So what this cutaway means is this is the equator is on the middle of the map. This is the Western Pacific Ocean and the Eastern Pacific Ocean. And the direction of the winds, kind of like this. Now, the thing about where you end up with the greatest amounts of precipitation happens to be where the water's warmest. Wherever the water's warmest, you get the greatest amount of evaporation, the greatest amount of cloud formation, and that's also the place where you get the greatest precipitation. As that warm blob of water moves across the ocean to being more in the center of the ocean, you expect greater rainfall rates in the center of the ocean. If that blob of warm water is all the way over toward the Americas, which also affects us even up here in Pennsylvania, you get greater evaporation rates. And it turns out the greater evaporation rates in the Eastern Pacific Ocean, that moist air can get carried up along the East Coast to get us rain where we are, like up in the Northeast part. That's like Florida here. California is like over here is Mexico, and this is like northwestern South America. This is Australia there. So there's a couple of good diagrams on that site. Okay, the other site that's important is NOAA has a climate site, climate.gov/ENSO. And this shows the current state. So this is the same kind of site as this one for Australia. So this is a site specifically to describe the current state of El Nino and La Nina. And right here it says current status, and here is a picture of the Pacific Ocean. You can clearly see like California's up here, here's Mexico, Central America, and there's the equator. It's a false color image showing what the temperature of the ocean is relative to what it should be. So if all this ocean was all like white right now, that means typical temperature. Anywhere where the water's blue is cooler than it typically is. And anywhere where it's red is warmer than it typically is. So it looks like here in Baja California, and this section of the Eastern Pacific Ocean, that's Hawaii right here. This water is cooler than it normally is. But then north and west of Hawaii, the water is significantly warmer than it normally is. By normally, I mean like, we have records of what the water temperature is over the course of decades. And so if the water over here is super, super, super warm, that's different than if it's really, really cool. So the current status, it says there's a La Nina advisory. So we're in a cool phase in the Eastern Pacific Ocean. And then there's another thing here. What is ENSO? And I refer you to that in the thing. So if you click on U.S. Impacts tab, you can click on Winter Temperature and Precipitation. So in the U.S. Impacts tab, um, this shows like what it's like in El Nino winters and La Nina winters. So now, if it's an El Nino winter and it says drier, and that kind of gets up into Williamsport, that does not necessarily mean that you're definitely going to have less snow. But the trend is that in those years, you usually get less snow than otherwise. And then in La Nina years, it says wetter and warmer. Those are years that we generally get like it's more rain than snow, more warm than cool. So if it's like, if it's August, September, October, and there's an El Nino that's cranking, and it looks like it's going to be set in place for like months to a year or two, then it gives you information about, what you can expect in a certain part of the country. So different parts of the country, you get different effects. There's a global impact thing. So the global impact tab shows uh, for a La Nina year, December to February, what kind of general effects you end up with. And you'll see mostly on the map, the Pacific Ocean is centered, pretty close to centered on the map, because this is an effect that occurs in the Pacific Ocean. The same kind of weather phenomena does not exist in the Indian Ocean or the Atlantic Ocean. It's because of the enormous size of the Pacific Ocean without like land obstructing it that you end up with these big differences in current and wind speed that gets set up. So we really notice this oscillatory pattern most commonly with what happens in the Pacific Ocean. All right, so that's that. And then yeah, so number 7, go back, click on the global impact tab. The global impact tab is just the one that's up here. So the individual tabs on the site are these individual tabs like that. So anyway, you can look around on these sites, but what I really want you to do is to see and understand how and where you can get information from NOAA, National Weather Service, and whatnot. So like, here's a story. First month of Northern Hemisphere, spring 2021 was warmer than average across the globe. So there's always like, stories about global temperature anomalies. So like March 2021 as compared to the last 30 years, this shows the temperature anomaly, which means like anywhere where it's red to maroon to black is much warmer than normal, and anywhere that's blue is cooler than normal. So there are some places in the Earth that experience warm times and cool times. This is a precipitation departure. In other words, like for March 2021, the March we just had, these are precipitation anomalies. So what this means is if the dot is toward the green, those are places that got more precipitation in the month of March than typical. And anywhere that's in the brown is places that are drier. So you can see here in the United States, the western states were relatively dry. Here throughout the central Midwest, in the grain belt, lots and lots of precipitation, drier in the east. And then in Australia, looks like they had a pretty wet March. Lots of green, not much brown. Europe looked like it was relatively dry. And then through Russia up into Siberia, Eastern Asia, relatively wet. So these sites have all the stuff you ever want. This, let's see. Yeah, sea ice max. So the white was the extent of sea ice at a maximum this year, and the yellow line is the typical extent of sea ice. So this year was a little bit low on sea ice. Anyway, there's a tab here about oh, this is from 2013. This is anomaly in sea level. So if it's bluer, sea level's higher than normal. Brown, sea level's lower than normal. All right, so you can use your Chromebook, and the best way to go is to go to when you're in the course, then on the right-hand side, Like if you're in materials or on updates on the right-hand side, it just says El Nino Webquest. You just click that and visit the sites and organize your stuff. Thursday is good. Yep. You can do it right now. You could. We could do some, I don't know, whatever else.